face AB refracts and is incident on the critical angle at face AC, and finally emerges out from the face BC as shown. Find the refractive index of prism and angle of incidence. You have to calculate the mu and this one. This is equilateral prism. He has given this angle. Now, again, the higher approach would be same. Let this be R1, R2, R3. These are the angles. Now this R1 plus R2 should be equal to 60. Already we have worked out. Huh? So sir, not understanding. Okay, I'll no, these two will, this will make an equilateral, so like a cyclic quadrilateral. This angle and this angle should be 180 and we'll get a one triangle. So from there, what we get is like, I'll write down this alpha, this beta, this is L1, this is P2. From cyclic quadrilateral, so this is N, LMN, we'll use instead of. So ALP1M in the quadrilateral, ALP1M alpha plus 60 equal to 180 degrees. Then in the triangle, LP1M, I'll increase the font size. So alpha plus R1 plus R2 should be equal to 180 degrees. So from here, similarly, quadrilateral CMP2N, this should be equal to beta plus 60 equal to 180 degrees. So triangle NPN, this should be equal to 180 degrees. So solving all this, again we'll get it as R2 plus R3 equal to 60 degrees. Okay. Now we have this relationship. So now find the refractive index of the prism emerges out from the face BC. So here it will undergo. So now let's write some equation like sine I1 mu sine R1. So here we have to calculate the refractive index of material of the prism. So we don't have any further information of like the total deviation. All that information is not available like previous problem. Check it. If you want to can calculate, but that information is not available for us. You have to calculate the refractive index and angle of incidence. Only this information is available. Is it R1 equal to R3? Comparing these two. Yes, R1 equal to R3. If R1 equal to R3, then sin I1 equal to mu sin R1. Mu, therefore, I is equal to 35 degrees. This just only by comparing things I brought expression for angle of incidence. Now we have to calculate the mu of a prism. That way, let me take help of at n. I'll apply Snell's law at n. Mu sine R3 mu is what we needed, sine 35 degrees by sine R3. Sine 35, I think, let me check with the calculator. 0.57. Sine 35 degrees, so 0.57 sine R3, sine of 60 minus R2, I'll write it. This will expand cos R2, I'll write it as so it undergoes TIR, no? Undergo TIR. So if it undergoes TIR, sine R2, I can write it as 1 by mu. So this will become root 3 by 2, 1 minus 1 by mu square. Mu root 3 by 2 mu square minus 1 by 2 equal to 0.57. How do this equation came? The denominator I'll send it to the numerator. The denominator in the RHS I'll send it to the numerator in LHS. Okay, this mu square minus 1. So 1 by mu square under root will be 1 by mu. It will get eliminated. We get so solving. I'll get the mu value 1.58. This will be your answer. Okay, check it again. The method is same. Where all TR comes, you see the formula of the sine of critical angle equal to 1 by mu. The reason for that we are using is like the other medium is air. I need not to mention that. Okay, this is air, no? Usually we do all our experiments in a room, in in air itself. So surrounding medium by default will be air. If it is other than air, I'll mention it. Okay. Again the same first relationship between angles, then applying Snell's law. So then the idea of TIR,